Hello to everyone.
Hello.
Okay. Do you want to ask me about anything? I'm ready to answer.
Test questions for tomorrow?
For the test, I am planning to talk about that. Besides this, yes, I will talk about this as well. Do you have any other questions in your mind? No?
No, I think we're good.
Okay. I am waiting until more people can be here, and I'm looking at your names right here. So this why probably in about maximum 5 minutes, I will be talking about this coming test. So today is May the 6th. Let me actually remind you about the last day of our semester for this class. It is in your syllabus. I'm just looking right now at that hard copy of syllabus, which I sent everyone electronically. And May the 15th is the last day of class. And May 20th from 11:10 a.m. up to 1:40 p.m., which is not our regular class time. This is from the special schedule for finals. We will have our final, just like a reminder. So I will check attendance very quickly, and after that, I will talk about the test. Andrew? Tima? I saw her name. Tima? Lorraine?
Here.
Lynn?
Here.
Juanita? Yuran?
Here.
Gabriel?
Here.
Divina?
Here.
Chantal?
Here.
I saw the name of Chantal, first one which when I turned my Zoom on. So, and here, Gongxi,
Here.
Kyle,
Here.
Matthew,
Here.
Julian,
Here.
Nathan,
Here.
Alejandro.
Here.
Okay, so let's talk about the test. I have a hard copy of that test, and I will see what we'll decide to do, because again, I need to decide what to do today after I'm done with all my lectures. But it will be just one of two options. Or I will send you this as an attachment to entire class, as I already did, if you remember, with one of quizzes. And you need to finish your test in the required time, and after that, send to me back after the end of that test. So I will grade, and I will send everyone your grades. Or the second option, I will offer this through Wiley Plus product, as I already also did already. But it will not change the topic for this test, because it will be in one version or it will be in another version. But the problems, the type of problems and number of the problems will not change. As you remember, I traditionally was releasing you quite important information about how many problems I would be offering you at this test and the type of problems. If you want to get this information, I can definitely release it to you right now. Would you like to?
Yes.
Okay.
Yes.
In this case, please try to write this down. I'm talking about this information in quite fast manner. Okay. I am planning to offer you 10 problems in total. So how many problems in total? 10. The topic for this test is trigonometry and applications of trigonometry. In problem number 1, you will be asked to simplify trigonometric expression. In number 2, I will offer you an equation. In number 3, you will be asked to list properties and to graph a given trigonometric function. In number 4, you should prove provided identity. Trigonometric identity, definitely. And after that, it will be an application of trigonometry. I would offer in number 5 an operation which you need to perform in algebraic form. So and actually I'm asking about the same thing in number 6 and number 7 and number 8. In 5, 6, 7, and 8, you will be asked to perform indicated operations in the algebraic form of complex number. Algebraic form is same like Cartesian form or rectangular form. We already talked about that. What kind of operations in algebraic form? A multiplication, raising to the certain power, second or the third, division of complex numbers in algebraic form, and in problem number 8, it is the problem like where you have to use different powers of unit I. So far, so good?
Yeah.
In 2 other problems, last problems, number 9 and number 10, there will be a different request. What kind? Perform the indicated operations with complex numbers in polar form. Give your answers in algebraic form. Practically, it is the same type of problems which we had, which I solved by request of Lynn yesterday. This is that type of problems. In 2 last problems, you need to express them in polar form. Actually, in one of problems, it is already given in the polar form. but your answer, final answer, should be in algebraic form of complex number. That's it. Now, looking at this all list of topics for that particular test, would you like to review anything?
Yes.
I heard, I think yes, right?
Yes.
Which part?
Applications of trig for any of those questions.
Application for trigonometry, you mean performing operation in polar form and giving answer in algebraic form?
Yes, please.
Okay. Agree. Let's find some problem in our textbook and I will go from there. This was in section 9.6. Okay. 1 second, please. Okay. Would you like to look, let's say, at problem number 21 on page 392? Problem number 21. Is it okay with you if we choose problem number 21?
Yes.
Yeah.
Yes.
Okay. Let me grab a piece of paper. I'm copying right now your page number 392. I can hear some strange sound. It is produced by someone's computer. So I would like to write this in more, a slightly different form, but don't worry. It is same problem. Do you understand that it has the power of 1/2? I wrote this like a radical to make it closer to what you would see in your test.
Yeah.
Yeah.
Okay, so what do we see here? We see in our radicand square root of 3 plus I. So this is definitely is a complex number. So what I'm going to do, I will bring this to the side and I will convert right now this into polar form. So let's say we name this radicand like using letter Z. Z is equal to square root of 3 plus I. Algebraic or Cartesian or rectangular form. They are all synonyms. We know that this form looks like x plus yi. Is it correct?
Yes.
Yes.
Yeah.
Let's find values of x and y for our number. So x equals square root of 3, y is equal to 1. Do you agree with me?
Yeah.
Yes.
Okay, let's first find r, the modulus or absolute value of that number. Absolute value of any number is the distance from that number to the center of the coordinates system, which we call origin in the Cartesian system, and we call it like a pole in polar system. distance. Distance all the time is absolute value, but this is not a regular real number. For the regular real number, absolute value of any real number is the distance from that number to 0. This is a complex number. This is why the formula for that distance looks more complicated. So r is equal to x squared plus y squared under the square root. Yes?
Yes.
Yeah.
Okay. Let's plug our numbers. Square root of 3 squared, is it just 3?
Yes.
Yes.
1 squared is 1. I'm even showing all details. It will be square root of 4. Square root of 4 is 2. We know that x is square root of 3, which means it is a positive square root of 3. Y is equal to 1, which means positive 1. This is why I'm stating that x part, which is the real part of that number, and imaginary coefficient are both positive. Are you okaying that?
Yeah.
Yes.
Give me the location of that
Quadrant.
number. Which
Quadrant
quadrant?
1.
Did you say 1?
Yeah.
I also say quadrant number 1. This is very important because I need to find right now the polar angle for that number z. For that case, I will be using formula for the tangent of that angle, because here it will be y over x. X is not 0. X will be equal to 0 if the point is located on vertical axis. In this case, it will be just an imaginary number for which a real part will be 0. But it is not the case. So, which means I can perfectly start looking for the tangent of theta. Tangent of theta equals y over x. In this case, it will be y is 1, x is square root of 3. In other words, tangent of theta equals square root of 3 over 3 after I multiply top and the bottom by square root of 3, trying to remove irrationality from the denominator. So now we are equipped by the following information about theta. Tangent of theta equals square root of 3 over 3. Because complex number z is located in the first quadrant, it means that theta as its polar angle belongs to the first quadrant. Which means we need to think about value of that theta, of that angle, because which angle is having positive square root of 3 over 3. It can be angle from the first quadrant or from the third quadrant. In first and the third quadrant, tangent is positive, and the second and fourth is negative. But we already know it should be in the first quadrant. So question is, which angle from the first quadrant has tangent of square root of 3 over 3. In other words, you need to find arctangent of square root of 3 over 3. Give me that information, please. Theta equals to what?
Pi over 6.
I heard this from only one student.
Pi
I
over
think it was
6.
Lorraine. Is it everyone's opinion?
Yes.
Yeah. Pi over 6.
Yes.
And you are correct. Theta is equal to pi over 6. Now I am equipped by two pieces of information. I know that r of that number is 2. I know that theta of the same number is pi over 6. Can I now write this in the polar form?
Yes.
Yes.
It will be what? Can you help me, please?
2 comma pi over 6.
Uh-huh. What do you prefer, pi over 6 behind I or in front of I?
In front of I.
In front. Okay. This is on the bottom here, that polar form of that particular number. It was given in algebraic form. Now it is in its polar form. Can I continue?
Yes.
Yes.
Yeah.
I'm coming back to my problem and I'm writing square root of 2e pi over 6 times I. So now it is in different form. Same number, complex number, which was given originally in its algebraic form. Now it is in its polar form. Okay, and now let's proceed because we need to perform this in the polar form and finally convert this again back to algebraic form. What I'm going to do, first, when we talk about square root of the product, and I definitely can't talk about the product because under the root, I have a product. It is 2 times that power with base e. So it will be square root of 2 times square root of e to the pi over 6i. Agree?
Yes.
Yeah.
I will keep that square root of 2 unchanged, but I will convert this e because it will be much easier. Definitely I can perform this operation having that root, but I like to do that in that form, which will be easier for students. So it will be pi e to the pi over 6 in parentheses to the 1/2 when I converted a radical form into exponential form. Can we do that?
Yeah.
Yes.
Yeah.
Okay, just again, few people participate. Please, guys, be more active. Square root of 2, how do we raise that power in parentheses to that 1/2 as a power? Should we keep e?
Yeah.
Yes.
Should we multiply exponents?
Yes.
Yes.
If you multiply pi over 6i times 1/2, what would you do? What would be your result?
Pi over 12. I.
Right, please don't miss that I. I performed that operation in its polar form. This is the end of the polar form. This is the problem when I was not asked to find all values of that square root, because if it is a square root, I should have 2 values in the set of complex numbers. This is the end in the polar form, but I cannot declare this as a final answer because my final answer should be in algebraic or Cartesian form. So what I'm going to do, I will be using very helpful trigonometric form right now to convert that e to that power using Euler's formula into trigonometric form. So it will be square root of 2. And if you remember Euler's formula, it lets us convert e to the theta I into cosine of theta plus I sine of theta. This is what I am using. My theta here is pi over 12. So it will be square root of 2 at the beginning, open parenthesis, and in parenthesis now what you have, cosine of pi over 12 plus I sine pi over 12. In trigonometric form, we all the time place I in front of sine. This what we have. Now, pi over 12 is not our reference angle. Reference angles which we widely use in trigonometry are pi over 6, pi over 4, pi over 3. Besides that, we have quadrantal angles like 0 radians. I'm just talking, listing in, let's say, radians, but we can have their equivalents in degrees as well, as you know. So 0 radians, pi over 2, pi, 3 pi over 2, 2 pi, and that's it. So you are not asked here to give your answer in this certain form calculating, but let me show right now exact answer and approximated answer. Definitely, if I like to have really long solution proving many things, I can treat pi over 12 like a half angle with respect to pi over 6, use trigonometric formulas and using values for pi over 6. I promise you, I definitely can calculate values for pi over 12, but I do not want to because the problem did not ask me about that. What I'm going to do, I will proceed right now to the exact answer, because you need to understand that even though on this last line, which we just have right now, we have cosine of pi over 12, which is a number, and sine of pi over 12, which is just another number. Yeah, they look a little bit nasty from point of view of normal people because they prefer to have, let's say, 5, 6, 7, 1/2, -3/7, not just cosine of some angle, sine of some angle, but cosine of any angle, or sine of any angle, or any other trigonometric function of pi over 12. They are numbers. This is why I'm going just distribute. It will be square root of 2 times cosine of pi over 12 plus I square root of 2 sine of pi over 12. In these situations, it will be normal if you write that it's square root of 2 and after that I and after that sine of pi over 12. But I wrote it in that form. And actually, I am boxing that. This is my answer. This is my answer in algebraic form, and this is my exact answer. This is my exact answer. And because here they did not tell us to approximate, probably maybe in your answers on Wiley Plus, this will be mentioned as an answer. But you know what, when your answer looks quite strange, it will be not a bad idea, even though if you are not asked to do that, I would let you approximate. So that first you need to get that exact answer. And look what I did. I put approximately equals. I need to grab a calculator, just 1 second. So, oops. So, and I'm going to enter these things not separately, just like one piece. I'm talking about one piece for a real part and imaginary part, that will be second step. Please first check your modes. Be sure that your mode is in desired mode, because again, this angle here is in radians. So my calculator already has on the third line word radian highlighted. So I'm not going to change anything. So I'm starting with, this is square root of 2 times cosine of pi over 12. This is what I'm going to enter. Square root of 2. So second button, x square button, 2. Don't forget to close parentheses. If you don't do that, your cosine of pi over 12 will be also under the square root sign. Multiplied, okay, you can skip multiplication sign, but I really like to have peace in my mind. I put multiplication sign. Cosine, okay, cosine. Cosine of what? Pi over 12, second button, corner button, divided by 12, and close parenthesis. And I will show you what I got on my screen. Square root of 2 times cosine of pi over 12. Is it what we had for the real part?
Yes.
Push enter. Let's round to the nearest, let's say, 1,000. So approximately 1.366, because after last 6, I have 0. I hope you are doing this also. Now, plus second part, imaginary piece. So same thing, square root of 2, close parenthesis, times sine. This time it will be sine, and again, second button, square corner button of pi. I already have pi divided by 12, close parenthesis, square root of 2 times sine pi divided by 12, push enter, plus 0.366, and don't forget to attach I. And this is your approximated solution. So there was no need to use a lots of trigonometry to come to the same approximated form. So this first box is your exact answer. The second box is your approximated answer. Did you understand the process?
Yes.
Yeah.
Yeah.
Okay. Now, would you like to see another problem? Slightly different, but with same procedures?
Yes, please.
Sure.
Okay, in this case, I'm going to probably create my own problem. Let's say you have two complex, let me grab a piece of paper. Let's say you have two problems. You have problems where you have Z1, first Z as a first complex number, and Z2, the second one. And let's say our Z1 equals negative square root of 2 over 2 plus positive square root of 2 over 2i. And let's say Z2 equals square root of 3 over 2 minus 1/2 of I. I just wrote these two complex numbers in their algebraic form, as you can see. Can I say so?
Yes.
Yeah.
Okay. What should we do? We need to find the product of these two numbers, but not in algebraic form. I need to find Z1 times Z2. This is why I told you about slightly different problem, because it is not just, let's say, any root or any power of complex number given in algebraic, but we need to perform operations in polar, come back to algebraic. This is slightly different type. We need to find the product of two complex numbers, but we need to find this product using polar form, but finally we need to come back to algebraic form for the final answer. Is it clear to everyone?
Yes.
Yeah.
So what would be my first step here? My first step here will be a conversion. I need to convert in Z1 and Z2 and their polar form. Let's start. For Z1, what do we have? X value, is it negative square root of 2 over 2?
Yes.
And
Yes.
Y value, opposite number to that, positive square root of 2 over 2. Now, what about this number Z1? Does it belong to first quadrant, second quadrant, third, or fourth? X is negative,
Second.
Y is positive. Did you say second?
Yes.
Yes.
Is it everyone's opinion?
Yes.
You know what? I share the same opinion. Definitely in the second quadrant, X coordinate is on the left side from the origin. It is negative. Y is above origin. Absolutely correct. Z1 belongs to the second quadrant. And now I will find R1, which is modulus for the first one. So it will be square root negative square root of 2 over 2 squared. Is it 2/4? And I
Yes.
purposely do not change it to 1/2 because I really like to have 4 downstairs because I have a square root here. Now, what about positive square root of 2 squared? Is it same 2/4?
Yes.
Yes.
If you are adding 2 2/4, what do you get? Is it 4/4?
Mm-hmm.
In other words, is it square root of 1, which is 1?
Yes.
Perfect. It is 1. So let's find tangent. But don't forget, because Z1 belongs to the second quadrant, your polar angle theta also from the second quadrant. In the second quadrant, tangents are negative. Excellent. So tangent of theta 1, tangent of theta 1 equals y over x. Are they having same absolute values? Only difference is in the sign. One is negative, one is positive.
Yes.
Yeah.
If you divide positive square root of 2 over 2 by negative square root of 2 over 2, is it negative 1?
Mm-hmm.
Guys, you are not very enthusiastic. Is it true?
Yes.
So now let's see what we have. If you like, you can even sketch small circle to find it. So I showed you a long time ago how to solve these problems with tangents. There is a tangent line touching. It is a vertical line touching your unit trigonometric circle at the point, what? With coordinates 1, 0. And this is the circle which has a radius equal to 1. So your negative 1 on the tangent line is below that horizontal axis. Can you see what I showed negative 1? Let me make this point a little bit bigger. Can you see that point?
Yes.
Connect this point with the center of the circle and continue until it crosses entire circle. And now I see here actually 2 angles in one revolution, but I will show 2 angles, but I will be interested only in one, which will be from the second quadrant. So these are 2 angles in that unit trigonometric circle, which both have tangent equal to -1. But I am interested only in that smaller. I am even showing that arrow right here. I need only that one in the second quadrant. So my θ1, can I say that it will be equal to pi minus that small piece right here? That is
Yes.
that small angle right here. Yes?
Yes.
What about that small angle? This is pi over 4, because tangent of +1, one tangent is equal +1, it will be pi over 4 reference angle. So it is pi minus pi over 4. So my angle is 3 pi over 4. 3 pi over 4. So, which means I already know that instead of Z1, I can write, I'm not going to write 1. Do I have your permission? Because 1 times anything is that number, okay? Do you remember we found
Yes.
R1 equal to 1? Okay? So which
Mhm.
means 1 times that E to that power, it will be just that E to which power? 3 pi over 4 times I. This is your Z1 in its polar form. E to the 3 pi over 4 times I. Do you understand where it is coming from?
Yes.
Because it is 1 times that E to that θ1 times I. In the same manner, I will find the same thing for Z2. So for Z2, X is square root of 3 over 2. Y is -1/2. What is the location? Z2 belongs to which quadrant? X is positive, Y is negative.
Fourth.
Fourth quadrant.
Yeah, and I already actually wrote it down that it belongs to the fourth quadrant. I'm going to find R2, which is square root of 3 over 2 squared. Is it 3/4?
Yes.
-1/2 squared. Is it positive 1/4?
Yeah.
Yes.
Perfect. Nobody even praises me saying that Dr. K is a good girl, that I decided to have R1 and R2 equal to very easy numbers. Can you please praise me a little bit?
Thank you.
I'm just goofing around a little bit. So we are again getting 4/4, and this is square root of another 1, which is another 1. Perfect. In the same manner as I already used for Z1, I will find right now tangent of that Z2. So tangent of θ2 equals, again, y over x. Here I probably will write down them because it is not the case when they are very similar. So it will be -1/2 divided by square root of 3 over 2. In other words, negative divided by positive is negative. It is 1/2 times 2 over square root of 3. We can cancel both 2's. And we are getting tangent of θ2 equals -1 over square root of 3 or negative square root of 3 over 3. So now I know that my polar angle θ2 should belong to the fourth quadrant, which makes sense because in the fourth quadrant, tangent actually is negative. And tangent of that angle θ2 is negative square root of 3 over 3. I can even roughly approximate square root of 3 approximately square root of 2 is about 1.21, but square root of 3 is approximately about 1.7 roughly. So 1.7, let's say it is even, we'll increase it a little bit. Is it about 1.8? 1.8 divided by 3, is it about 0.6? Yes?
Yes.
So which means if I sketch another tangent line, my tangent of that angle, which is approximately 0.6, will be at some place again below that horizontal axis. And I am going to connect that point again with the center. This time, I would like to show even only one angle, because there will be here two angles, one in the second quadrant and one in the fourth quadrant, which will have both same tangent equal to negative square root of 3/3. But I am showing just that one, desired one, which is from the fourth quadrant. This is my angle. It has a terminal site in the fourth quadrant. So let's find it. Can I say that this theta 2 will be equal that 2 pi minus that small angle? Yes?
Yes.
What is the reference angle if its tangent is equal to positive square root of 3/3?
Pi over 6.
Pi over 6. Good girl, honestly, because all others are suspiciously silent when I ask about these values. So if you have here pi over, again, 1 second again, your sine of this angle should be 1/2. So is it pi over 3 or pi over 6? Asking you guys.
Yeah, pi over 6.
Because y is sine of that angle, x is a cosine, so sine of that angle is 1/2, cosine is square root of 3/2, pi over 6, right? What
Yes.
happens if you subtract pi over 6 from 2 pi? 2 pi, is it 12 pi over 6?
Yes.
Excellent. 12 pi minus 1 pi, is it 11 pi over
Yes.
Yes.
6? 11 pi over 6, pi over 6 is 30 degrees, and 11 pi over 6 will be 30 times 11, it is 330 degrees. Definitely it is the fourth quadrant. Makes sense. Now I have all rights to continue with polar form performing this operation. So it will be 11 pi over 6 times I, and I wrote it on the top. Now I'm just going to multiply two powers which have same base I. When we multiply these powers, do we add exponents?
Yes.
Yes.
So look what we are going to have now, which means we have e to the 3 pi over 4 in parentheses plus 11 pi over 6 times I. And please perform this operation again in the polar form. So if you are adding 3 pi over 4 and 11 pi over 6, 4 here, 6 here in denominators, is at least common denominator equal to 12?
Yeah.
Yes.
Yeah.
In this case, you are increasing 4 3 times, so you need to increase the top. Is it going to be 9 pi?
Yes.
Yeah.
You had 6, now it is 12. Should you increase twice the top? Guys, yes or no?
Yes.
Yes.
So, and look what you are getting. e to the 9 pi plus here 22 pi over 12 times I. Add this. So it will be e 9 pi plus 22 pi. Give me the value.
Pi over 12.
I could not hear.
31 pi over 12.
Right, it is 31 pi over 12 and attach I. This is your answer in the polar form. E to the 31 pi over 12 times I. Now it is time to convert into trigonometric form. So it will be cosine of 31 pi over 12 plus I sine 31 pi over 12 and attach I. Because 31/12 is an improper fraction, can I say that this is at least, let's say, 24 pi? Listen carefully, 31, is it 31 pi? Is it 24 pi plus 7 pi?
Yes.
Guys, you are not sure? And you will see why I'm doing that. 24 pi plus 7 pi over 12 plus same thing with sine of 24 pi plus 7 pi over 12. And now I will separately divide first adding by 12, second adding by 12 in both fractions. So I am going to get cosine parenthesis 24 pi over 12. Is it 2 pi?
Yeah.
Yes.
Is it 2 pi plus 7 pi over 12?
Yes.
Plus I and same thing after sine. It will be parenthesis 2 pi plus 7 pi over 12. Do we know that and cosine and sine are 2 pi periodic functions?
Yes.
Guys, you are facing your test for trigonometry. Drop these 2 pi's. So you are getting cosine of 7 pi over 12 plus I sine 7 pi over 12. And this is your simplified answer given in trigonometric form. Grab your calculators. With this range, I can help you with calculator to find approximation, which I perfectly will accept. My calculator is in radian mode, so it will be cosine of 7, second button, corner button, 7 pi, or divided by 12. And I am approximating. This is approximately negative 0.2588, which will 259. And I'm going to enter sine right now. And now it will be sine of same thing, 7, second corner button divided by 12, close parenthesis. And I have another number, which is positive 0.9659. So it will be 966 times I. And I am absolutely done. Yeah, this is quite long process because we had both numbers given in algebraic form. It took some time to convert these two, Z1, Z2, into polar form, perform a multiplication in that form, and finally again come back to algebraic form for the answer. But I explained you all the details of the process. Is it clear?
Yeah.
Yes.
Do you think that this type of review was quite beneficial for you?
Yes.
Mm.
Do you let me finish? But before I finish, I would like to say just few words. Again, definitely I will come to the final decision if you do that through Wiley or to send you this like a separate attachment, in which case you have to perform operation and manage to send me back your test in the timely manner, or I will be doing that through Wiley Plus. I think through the Wiley Plus, maybe it will be a little bit faster and easier, but I need to come to that conclusion. And I will definitely notify you about what you need to do. In this case, you will be getting your attachment in form of the test to start on time, or I will send you an email saying that, you know what, please use Wiley Plus. It will be test number such and such, and you need to go directly to Wiley Plus, not visiting me. I will be available on the Zoom during that lecture, but you don't need to visit me because I will see the attendance because you will be working with your assignments. I hope I explained everything. Do you have any additional question?
It's going to be about an hour, right?
It will be, yeah, exactly the same allowable time as we usually had during regular face-to-face classes.
Okay, thank you.
Do you let me finish?
Yeah.
Yes.
Okay. I hope everyone can watch this video again or go over notes, and please review all trigonometric values and formulas. Definitely, I'm not standing behind your back, and you definitely have more freedom to cheat a little bit with values, but it will take much longer time. But if you know for sure all these values and formulas, it will be much, much, much easier for you. And I really like to see everyone getting good looking grades for tomorrow's test. Okay, guys, have a nice, beautiful day. And I'm finishing my today's lecture. Bye.
Bye bye. Thank
Bye.
you.
You're welcome. Bye.